Okay, so what I like to do to begin with, at the same time, you guys can also think about what you want to ask for your questions. I would like to maybe start very quickly from the Google Doc that I shared, so you can feel free to post questions there. At the end, I can just go over them. Why don't we start with these questions first? You can also interrupt me if you want any other clarification for the similar question. Okay, why don't we start with them, and then we'll see how much time we left, and then we can take new questions. I remember I saw something that I can just answer in 5 seconds. Where is the exam location? Lausanne Building A, all right? Over here. Sunday, August 26th, I believe. Yes, 26th, and that'll be 2 p.m., okay? 2 p.m., don't be late. Okay, so will you take marks off for incorrect multiple choice answers? No, okay, no. Hopefully that gives you some break, I hope. Okay, that'll be no. Okay, I think these two are the easiest to answer. Okay, let's get into business, all right? Okay, let's start from here. Let me just read it here, okay? So question 1, so about a two-dimensional array, example 4.1, slide 15. Let me go there, okay? Two-dimensional array, go to slide number 15, and let's see what we have. Two-dimensional array, okay? Slide 15. Okay? And 4.1, that's right. Okay, let's see what the question is. Would this program have sense? Would it work if we use all negative numbers, mixed numbers? Okay, basically the question is about if you pass different input values rather than assuming all positive, would it work? Let's just have a look at the program as a case study. Okay, let me see. Do you think that's big enough for you? Okay, right? Okay, good. Okay, let's have a quick look. So this one here is going to find out the maximum sum, right? I presume you at least had a look at that, right, before today. So for the maximum sum, let me just talk very briefly about the idea, okay, about the maximum sum. So basically, you're assuming that you can get any two-dimensional array, okay? Let me just say maximum sum over here. Okay, let me take off my watch. That'll be easier. Let's say, for example, over here, let's say we got over here, let's say a two-dimensional array that looks like this. Okay, how about just that? It doesn't have to be square. It doesn't have to be rectangular. You want your solution to be as general as possible. Okay, let's just try something very quickly. In case you have access to the slides, I want you, okay, the most important part is line number 2. Okay, if you're looking at a slide, I would suggest what I'm trying to explain, think to yourself, and then I'll try to answer as well. Think to yourself why line number 2 is necessary. What is line number 2 doing? It is basically to say we are trying to go over row number 0 only. You can see that A0 over here, right? Remember the first index you give is about a row. A row number always starts with 0. So we start with row number 0 and calculate exactly what the sum is and start from there, right? Just keep that in mind. Now the question is, would it work if we simply assign the maximum sum to be some arbitrary number, for example 0, or to be some maximum integer? Would it work? That's a question, okay? So now let me just go back there and illustrate some idea, and then we'll go over. Okay, let's see this. Let's say maximum sum. Let me just give you some idea over here. Let me make up some example on the fly. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so that's row number 0, row number 1, row number 2. Okay, 1, 2, 3, 4, 5, 6. Let me just make it a little bit longer. Okay, like that. Okay, so now what I would like to do is like this. So now let me just give you some number over here. Let's say 2 minus 4, and then 3, 7, 6, 20, and then 1 minus 2, 4. It's arbitrary, really. 1, 1, 1, 1, 2, 2, and then 3. Okay? and then I will have maybe -2, -4. Okay, something like that. Let me just illustrate to you, first of all, what does line number 2 do over there on the slides, line number 2. Okay, basically we are simply running a loop. It's not nested, just a normal loop. We're trying to figure out there is something called maximum sum. Before I talk about this variable here, let me give you an analogy over here, okay? Let me just put some analogy here, which can be highly related to how you solve this problem here. If you have an array, not two-dimensional, just one-dimensional, let's say you got an arbitrary number of elements over here, right? If you want to find out the maximum, in a 1D array. Okay, let's say somehow you just try to let me just say integer max, and then you give an integer array. Let's say A over here, right? Over here. Let's say you have integer max of A, max of array. Okay, and then you do some magic over here, and then eventually you're going to return max of A. Okay, let's say that. Okay, now here's a question for you for this simpler problem over here. So now I declare this variable here. Eventually I'm going to return its final value after a certain iteration. Now the question is, what should be the initial value for that? What should be the initial value? For example, let's say here, let me just make some example for you. If I have, let's say, -4, 6, -2, and then 20, 30, 100, and then -200, something like that, right? So now, what value should you assign to the max of A, right? If you recall what you did for lab test number 2, right? I believe one of the examples I gave to you. One strategy which will always work is to say, why don't we temporarily say the max of A is simply just the first one? Just say that, assuming that the array is not empty. So that means you always get the element at index 0. Okay? And then the max so far is simply just -4 to begin with. And then we're going to run the loop, starting from the second position in the array, and then we're going to compare every element against the current value of the maximum so far. If the current element is strictly larger, that means we got to replace it. Otherwise, we keep it the same. For example, let's say, let me put it here. So max of A, okay, initially it's simply just -4 to begin with, right? And then we can run a loop to go from index 1 until A.length -1, right? That's what we can do. And now the second element we are looking at in the first iteration is 6. So now 6 is strictly greater than -4, so we should replace it and put a 6, right, after the first iteration. Similarly, for -2, should we replace it? No, leave it the same. And then 20 here, replace it to 20, and 30 here, replace it to 30, and over here, replace it to 100, and the last iteration is smaller, so the final value should be 100. Okay, so far so good? So how can you relate this problem over here with the maximum sum? In some way, what you're calculating is the maximum sum from all the rows. You can think about this is the sum for the first row. This is the sum for row number 1, and this is sum for row number 2, all the way to A.length -1, right? So now we solve this problem just in a similar way. The only complication is row number 0 is no longer just a single element over here, right? You can see in the case of the one-dimensional array, it's a single element. But in the case of the two-dimensional array, it's the entire row. So that's why over here, the idea is the same. We just want to calculate for position 0. But now in this case, you can see on the slides, for line number 2, we simply want to calculate what's the sum for row number 0, right? And then for each row onwards, we simply want to say what's the sum. And once you calculate the sum for that particular row, you want to see if you want to replace the maximum row sum so far. For example, let's try, give you one example. So what's the initial value for maximum sum? So minus 2, 1, 8, 14, 12, and then 8, okay, in the beginning. Yes, thank you. Good, okay. You didn't miss anything, just calculation, okay, just 8. Okay, that's the first row. What about the second row? The second row, we're going to run some nested loop, but the nested loop is simply just going to calculate the sum for each row. I'll leave you the detail for that. And then, so what's going to be the sum for the second row? 21, 19, and then 23, right? That means we're going to replace it by 23, and so on. Guys, follow the idea? Okay, good. So now back to the original question. I just tried to explain a little bit the insight. To me, it is more important for you to understand that solving the maximum sum problem for two-dimensional array is essentially the same as solving the problem for finding the maximum in the one-dimensional array. You want to see the linkage. That's kind of the abstraction you want to have. Since now, unofficially, you're already in second year, right? So hopefully you are gradually to have that kind of mindset. Okay, good. Okay, let's go back to the question there and see. So now, would this program have sense if we use two-dimensional with all negative numbers? Yes, because you can see that in the one-dimensional case, it doesn't matter what kind of mix of the numbers we have. You can have all negative, you can have all positive, or you can have a mix of both. Similarly, for the case of the two-dimensional array, it will also work. Okay, but again, the most important thing for you to understand is line number 2 over there in the slides. Okay, line number 2. Okay, understand why we should really get the initial value over there. Okay, any question about this before I move on? We okay, right? Okay, since today is only review section, feel free to ask any questions you like, you know. Okay. All right, let's go on. Let's go back to the question there. E will make sense. Yes. Okay, let's see question number 2. It's about the API lecture. Okay, slide number 9. Okay, let me just go there. Okay, let me just leave two-dimensional array for now, and let's go to the API lecture. Okay, let's see what it is. Okay, it says slide number 9. Let me go there first. Okay, slide number 9. Okay, let's see. Okay, by the way, this slide over here, it's not very so clear, but you can also see the link for the API page. This is something you didn't really see many examples, only in one single lecture for 1022. But in the coming 2030, we're going to see lots of this. You're supposed to even make an API by yourself, like that. If you're in my section, I'll also show you how you can do it. But for the purpose of 1022, you just have to read it to begin with. Okay, let's see what the question is. Why array list method signature of add are of a Boolean type? Okay, add and remove. Let's see. Okay, it's a Boolean and Boolean. Okay. Guys, you see what the question is? Okay, let's see this. How do you read this API here? You can see over here, let me just go to the API page. Maybe it's easier to see. It was a good question, actually. Let me just go there. Array list, and we got this method here. Okay, let's focus on this one. For the remove, it will be something similar. Okay, let's focus on the one I'm just highlighting here. Okay, first of all, you can see that the method name is called add. And then following inside the parentheses, we have a list of parameters, right? In this case, there's only one single parameter. And for now, don't worry about this E over here. That's something too advanced for this moment. But that's something I will cover in 2030. It's something called generics. I will cover that later. Okay, the question was, this column over here is supposed to be the return type. For example, you can see that over here. Let's say, let me give you something that makes more sense. If you say contains, it's basically like if I give you one element to check to see if it is in the list, it will tell me either true, it is in the list, or false, it is not in the list, either true or false, right? But the question was, why in this case over here, add will also return a Boolean, either true or false? What does it really mean? My response to you would be, if you're reading some Java standard API, you have doubts. You should really check the API. They should usually give you more details. I'll show you. So if you go to click on add over here, and then what you will see is more details for the same method. Okay? Okay, it's something over here, returns true if as specified by another link you want to click on. Right? I'm just trying to show you how I find out the answer. Sorry? Yeah, it's part of this course, yeah. Basically, the question was why the add method for the array list returns true or false. That's the question. My response to you would be, if I do ask you this question here in the exam, I'll give you all the API information you will need. You definitely don't have to memorize the subtlety over here. That's my point, okay? I'm just trying to show you more beyond this course. What you should do is click on the link on the web page and find out the answer, okay? So that means we should go to this method over here, and let's try to, I'll try to highlight what you should really pay attention to. Okay, true if this collection changed as a result of the call. I can tell you what that means. I'll just give you one example. You can try it out. Okay, this is subtlety. Okay, I don't really want to say it's not really related to the exam on Sunday, because if I say that, you wouldn't study at all, right, for that particular one. But let's just try to learn very quickly. Okay, so now what we can do is, let me just go back there. I'll illustrate to you. That could be useful for your 2030. Okay, let me just go back to the method again, and now we'll write some example for you to try on Android Studio. Okay, let's just focus on this one here. Okay, it's going to be add. Okay. Okay. So let's make some example here. Let's say we have an array list of string. Okay, I'll say list over here is new array list of. Okay, for the purpose of this course, you do not have to worry about why you're using angle brackets and having string over here. You do not have to worry. All you have to know is we are creating a list of strings. You just have to know how to read the code for this course. But in 2030, you will have to know. But for this course, no. Okay, but just know how to understand the code. So now I will illustrate to you. Let's try this. Conceptually, after this line over here, what kind of list are we creating? Empty list. Empty list, okay? So the red part is simply just concept, okay? That's what you have in mind. And then let's say list dot, oh, actually, you know what? Let me, over here. This is one way you can use it. You can say Boolean. Let's say, I would say B, okay? Just Boolean B. Is assigned to, remember again, over there, according to the API, it's going to return a Boolean, right? Either true or false. So I'm going to illustrate to you what true or false, how it should be interpreted. If I say list dot add Alan, okay? And then before we can figure out what the B should be, so now let's see, what would the list become? Just one element there, right, after adding to the end. So I'll just use like array notation. So Alan is going to be the first element in the list, okay, conceptually. So now, question is, going from here to here, has the list changed? It has, from empty into not empty. So this is going to be false. Oh, sorry, true. I'm so sorry. True. It should be true. Why? Because if you go back there again, let me just double check for you. If you go back there, and then we should refer to the collection class over there. Let me just go there. Boolean add returns. Yeah, true if this collection changed. If it has changed, you just return true. Okay, that is why if you go from empty into non-empty, that should be true. Let me give you a case where it would not be true. Let's try the following. If I say Boolean, I'll say C is assigned to the same list dot add Alan again. Okay, just the same elements, the same. Now, if I do that, what's going to happen? You can see that the same list is going to be resulted from there. So it's going to be still Alan here, I believe. Okay? Follow so far? Okay, and then that should really give you false. That's my interpretation, but we gotta try. But there's something I want to say. If I do put this in the exam, what I will give you is I'll give you some little example, and then I'll give you the API information as well. What I'm trying to show you now is if you are given a lab or assignments like this, that's why you should check out from the API. That's more about the lesson I want you to learn. Okay? Yes? Yeah, it's a good question here. You know what? Let me try to see. True if this collection changed as a result of the call. You know what? I think I might be thinking, I think you're right. If you do this, I believe Alan will be added to the end. Because the list might contain duplicates, like an array. So that means if you go from here to here, the list has also been changed. So I think that will also be true, I think. I personally don't really use this Boolean return value usually. I only just call the list.add. So I would say, don't worry about this return value. How about that? Would it be okay for now? But if you still have concern, I will try to make some good example for you, maybe in 2030. That will be the appropriate place to illustrate. Yes? Yeah. Yeah. Mm-hmm. Yeah, so that's the thing I want to try. Guys, I don't want to waste your time. So what I want to say is, how about let's say for as far as this the exam is concerned for Sunday, all you got to know is list.add and list.add is going to add something to the list, right? And just follow the example I put on the slides. That's all I need you to know. And as for the return value over here, since I don't use this feature often myself, I don't want to give you something that's wrong. Okay, so don't worry about this Boolean part over here. Okay, I need to maybe offline to study this a little bit myself. Okay, so my response to this question here was Boolean type. Don't worry about the return value from list.add. All you need to know is that it appends something to the end of the list, as I illustrated in the class. Okay, that's all you got to know. Okay, but I'll try to keep this question in mind, so maybe in 2030 I can try to cover that. Okay, so would it be a void type instead? No, because that's what the API was defined. So you got to follow exactly. If they say Boolean, then it's Boolean. Okay. Okay, similar issue here. Okay. Okay, can I move on? Any question about other things about array list before I move on? Were you guys comfortable with the example I put on the slides? Was it okay? Hash table, array list. Okay. Okay. So now this question here I have covered. Let's go to number 3 over here. Okay, I should go to the loop lecture. Loops over here. Let's see which slide it is. It's something about indexing and short circuit. Should be 58 to 60. Okay? Okay? To 60. Okay. Somehow the question said It was skipped in the lecture, but I don't think so. I believe I covered that. Let me just briefly mention that again, okay? I'm pretty sure that's covered, okay? So now, I want to, okay, so basically it's about this, okay? First of all, what's short circuit? Guys, anybody can tell me? What's short circuit? Anybody want to try? It's okay to be wrong. What's short circuit?
Is it like the loop exits before it checks the second condition?
No, short circuit can be applied even without a loop. So it's not really about early exit. Okay. Not really. Anybody want to try? Short circuit? Yes. Yeah, something like that, exactly. So short circuit is, I'll just briefly mention that, and then let's see what we can do. Let me go to iPad here. Short circuit is really important, okay? Let me summarize what short circuit is. It's important, okay? So now let's go a little bit about logic here, okay? So now, short circuit is something like this. Let's say you got Boolean variables over here, Boolean B1, and also Boolean B2, right? This can be either true or false. This can be also true or false, right? And now, in Java, when you say B1 and B2, okay, let's talk about this first. Any one of you has taken 1019, the logic course, okay? I guess not very many. Okay, let me just briefly talk about a little bit about logic. How about that? Just to make sure it's properly covered. Okay. So now in logic, we got two operators you want to know. One is called conjunction. Conjunction simply means and. Okay, you want to say something and something. Okay, and usually it's a binary operator, which means there are only two operands for the operator. Let's say B1 and B2. So now for B1 and B2, we know that B1 can be either true or false. B2 can also be true or false. So that means how many combinations we have? 4, right? So it can be either true, 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 false, false, true, and also false, false. Okay, so these are all the input combinations here. Okay, and then the ampersand is Java's version for conjunction. You know what? I'll put this in a quote because it is not exactly conjunction you would think mathematically. It has slight complication added to it at the runtime. Okay, I will explain that in just a moment. But let's talk about logic first. If you say B1, I would say and B2. Okay, so now the principle is very easy. Conjunction, you want to say something is true and something is true. Overall, both of them are true if B1 is true, B2 is true, right? So the only way you can make the result true would be when both of them are true. In other cases, it could be either because B2 is false, or it could be because B1 is false, or it could be both of them are false, in which case the result will just be false. So the only way to make B1 and B2 true is both of them are true. Okay, that's from the logic point of view. Okay. Now, how does this affect the short circuit effects? Short circuit effect goes a little bit more to it, goes a little bit more. Let me just give you one example here. Okay, one example here. Okay, let's say over here. If I say x not equal to 0, okay, and conjunction y divided by x is larger than 2. Let's say we have that, okay? So that's the left expression, that's the right expression. We've got two expressions over here, okay? So now, let's not worry about short circuit just yet. Let's not worry about it, okay? If, let's say, for example, let's say, if y is 4, x is 0. Okay, what's going to happen? Let's say, let's not worry about short circuit, which means you have to evaluate this to get true or false. you also have to evaluate this and get true or false. And whatever true or false you get from both sides, you want to see, according to this table here, if the overall result should be true or false, right? But what's going to be the problem over here? X is actually 0. So that means 0 not equal to 0 would be false. No question about it. However, if you also try to evaluate the right-hand side, something divided by 0 is undefined. You will simply crash your program at the runtime, right? So this side will crash. Okay? We just talk about from the logic point of view. If you want to do simply just logic, you have to evaluate both sides. However, Java as a programming language does something very clever for you. This is what it does. It's going to evaluate not both of them to begin with. It's going to always evaluate the left-hand side first. Okay, I'll write it down, the key points. Evaluates left to right. Okay, evaluate from left to right. And now, if you evaluate the left-hand side first, you will get false, right? In the case of conjunction, if you already got one of them being false, what's gonna be the result? It's gonna be false anyway. It doesn't matter what the right-hand side is. So that means you do not have to bother evaluating the right-hand side anymore. Okay? So now, evaluate from left to right, and then in the case of conjunction, okay? In the case of conjunction, if the left-hand side is false, so what does that mean? That means overall is false anyway. So we can simply skip evaluating the right-hand side. Okay, that's a case of conjunction. That's the story. Let me give you some counter example. Okay, let me say this one over here. If I swap the order, if I say y divided by x larger than 2 and x not equal to 0. Logically speaking, if you say p and q versus q and p, they are the same. Logically speaking, they are the same. If you say 2 plus 3 versus 3 plus 2, they are the same, right? But now, is the short circuit going to help you over here? It may, is it going to help you in the case? Again, short circuit means you're going to evaluate the left-hand side over here to begin with. But left-hand side is going to crash first, so you'll never get to the right-hand side. So the order of evaluation here is the key. So you can also refer back to the slides. I don't have to waste your time here. So over here, what I said on the slides was, over here, this is the so-called guarding condition. So what is called a guarding condition? In order to evaluate the right-hand side over here, we want something on the left-hand side to protect. To say if x not equal to 0, if it happens to be false, that means x is 0. Which means you may just crash this program. So that's why I put it on the left-hand side of the conjunction. And the short circuit at the runtime is going to sort it out for you. Guys, is that clear for conjunction? Okay, good. For disjunction, let me go over very quickly. For disjunction over here, let's see. So one thing you want to keep in mind, in 2030, I'll try to draw more attention to math. So since we're studying computer science, so it's not isolated from math. So many things that you learn from 1019 and 1090, they will eventually come integrated into your third year. A course called 3311, software design. Okay, just as a preview. Anyway, well, if you take it with me, then don't have to worry. Okay. Anyway, okay, let's now just do very quickly the disjunction. Okay. So now let me just be precise because this is a really important topic. We may not be able to cover short circuit again in 2030, but I hope at least you can get some understanding here. B1, B2, okay? True, 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 false, false, true, and false, false. Okay, and now B1 or B2, okay, or. So the idea is kind of the opposite. We want to know if either B1 is the case or B2 is the case. Overall, it would be the case if either one of them is true, right? So now you can see that in this case, we know one of them is true. Here, one of them is true. Here, one of them is true. So overall, it will just be true. The only case where the disjunction would be false is when both of them are false. So it will be false. Okay, what does that mean in short circuit? So the short circuit applies to both conjunction and disjunction. Okay, let's try that. Let's try this one here. If I say, let's do the similar example like this. Okay, I'll give you the correct version. X equal to 0 or y divided by x larger than 2. You can see one thing here I want to draw your attention. You can see over here I say equals equals as opposed to not equaled because I'm changing the operator here from conjunction to disjunction. Okay, notice that. Okay, let's see how the short circuit effect is going to work. Let's say the similar example, let's say 4 and x is 0, y is 4. Let's say over here, okay? And now, what would be the short circuit effect is going to be left to right. And what's going to be this left-hand side? 0 equals 0, true. So true means one of them is already true. That means the overall result must be true. Then you don't have to bother going to the right-hand side. It's going to be true anyway, right? So that means we don't have to go there, okay? So now, so that means we can avoid evaluating this. Okay, on the other hand, let me just change the order over here. If I say y divided by x larger than 2 or x equals 0. Would that work though? Would it crash? It would, right? Because if you evaluate, you always evaluate the left-hand side first. In this case, x happens to be 0. Something divided by 0 will crash. So you crash this without giving a chance to go to the right-hand side, right? So the order really matters. Okay, are we okay? Okay, one more example, okay, about short circuit. And tell me which one is correct, okay? Let's say we have some integer I. Okay, integer I is assigned to something, okay, some value. I wouldn't be specific about what that value is. Integer array A is also initialized to something, okay? I'm not giving you some example over here. Tell me which one should work, okay? If I say okay, let's see this. Okay, a dot length. I want to check if AI is larger than 3, for example. Okay, that's number 1. Okay, I'll just give you 2. You will see the complete numeration on the slide as well. Okay, that's version 1. Let's see version 2 as well. I less than a dot length and AI larger than 3 and 0 less than or equal to I. I'm pretty sure I covered this other possibilities in the lecture. Please do check, but I'll reiterate anyway. Okay, now, your time of decision. Is number 1 problematic or not? No. Okay, that's correct answer. Okay, let's just go over number 1 very quickly and then we'll see why number 2 is actually problematic. Okay, let's see, just see some normal value. Okay, so now let's say A happens to be an array, let's say 2, 3, 4, 5, 6. Okay, and now let me give you some illegal value and not the criterion to judge how if the short circuit is applied correctly is to see if your program will crash or not. Okay, so now what if I is simply just -1? Okay, let me use a different color here. Okay, What if I is simply just -1? So now that means 0 less than or equal to -1, true or false? False, right? So that will give you false. That's a leftmost evaluation. If it is false, for conjunction, do we have to bother evaluating the rest? Nope. So now that's it. Overall, you will just be false. So you will never even get to this point, because if you can ever reach this point here, so that means A at index -1 will give you array index out of bound exception, right? Okay, so this is good, okay? What about I give you another value over here? What about give you something that's too large? You can see over here 0, 1, 2, 3, 4. What about give you 7, for example? Okay, now if 0 less than or equal to 7 over here, should that be true or false? True. So that means if it is true, we should evaluate the rest. And the rest is over here. And for that kind of, and then for that, we should really evaluate this first, always left to right. Okay, so now I is 7 over here. What about A.length? A.length would be 1, 2, 3, 4, 5. Now 7 less than 5 would be false. So that means this guy over here is going to give you false. Now short circuit tells you if you already get false, overall it's going to be false anyway. Don't go ahead to the right. So now again, it will prevent you from crashing the program. Okay? So this program does work for either the value that's too small or too large. So now for number 2, okay, you can see that number 2 is pretty much like number 1, except that I kind of moved the order for this guy here. Used to be here, I put it here. Okay, that's the only difference. Now the question for you, is the runtime behavior going to be the same or different? Version 1 and version 2. Logically speaking, they are the same, logically. However, this course is not just about logic, it's about programming execution. For version 2, if you do not think they are equivalents, give me one example where it will show the difference. Give me one input value of I. Anybody? Give me one input value. How about let other people try? I will get to you. I'm pretty sure you know. Anybody want to try? This could be on the exam. Yeah. If you want me to compare this versus the add method returning true or false, I'm more interested in this, much more interested. So it's more important for you to know why. Guys, let me give you a little bit hints. If I give you this question here on the exam, how can you judge? First of all, for version number 2, you know that the condition is going to be checked from left to right, right? So that means the leftmost expression over there, think about that. Thinking this way here, this leftmost expression is going to be evaluated first. If it is false, that means okay, let me just put it here. False if I is larger than or equal to A.length, the negation of that, right? That means I is too large. It will give you false if I is too large, which means it's going to stop right there. It's not going to go further. Okay? So that means this one will properly protect the case where I is too large. So now it makes sense to ask, does it really protect you from I being too small? Do you want to say something? Yes. Go ahead. Say that answer again. Give me an input value of I that's going to crash the program. Any negative number? -2, -1. Good. Very good. That's exactly correct. Because you can see that, okay, let me make it more visual for you. You can see that over here. Let's see the blue part over here. So this is the guarding condition. Okay, let me just apply the same logic over here. So this will give you false if 0 is larger than I. I is less than 0, basically, right? So this will be, so that means I is too small. So this seems to be a guarding condition. Guarding condition, okay? However, the problem is you put it in the wrong place. This guarding condition is actually put after the thing you want to guard is executed. You see what I mean? you should really try to put all the guarding conditions all together to the left of the expression you would like to guard against, right? Because we know that this is really the key thing we want to evaluate, right? Where we're going to use the value of I over here. You want to make sure I is neither too small nor too large. That's why you have to put these guarding conditions to the left of that, right? That's why number 2 is not going to work. Specifically, crash when I is too small. Okay, can everybody see it? Okay, so the same idea applies to if you do disjunction or you do other expressions. Okay, I'm just trying to explain this one in details. But I believe this one was covered maybe back in maybe early February. You can maybe check the lecture, right? That's a long time ago, I know.
How do you decide which condition would be the guarding condition versus not? Like, how do you decide?
Oh, I see. The question was how did I see that they are the guarding conditions? In this, okay, very good. So okay, let me make some general principle for you, right? Over here, let's say if you look at this condition here, when you say AI larger than 3, whenever you see anything about array indexing, right? That's about array indexing. It's a very common error for you to get array index out of bound exception, right? That's something you saw a lot, maybe in lab test 2, maybe. So now array indexing, so whenever you got array indexing, you want to guard it. Whatever expression value you put over here, you want to make sure it's larger than or equal to 0 and strictly less than a.length, right? That's kind of the guarding condition for array indexing. Another one that's very normal to have. Let's say you have a method call. Let's say if I have p dot method, p dot m, for example. Okay? So now, when can you get a null pointer exception for p dot m? If p happens to be null, that's when you get a null pointer exception. So in this case, how can you guard it? Okay, let's do that very quickly since I mentioned that. Okay, so now let's say this. Let me just make it like that. Person P is something. Okay, something over here. Okay, now if I say something like this, P dot get name, for example, very easy. Okay, it's a very quick review. So this is a method we are trying to call, right? And this P over here is so-called a context object. And remember I said many times, if you say p.getName, what does that mean? P is supposed to store the address of some person objects. It is supposed to. Okay? So now, if there is, well, and what does that mean? Let me give you a quick example here. If I say person P is new person, Alan. What about in this case? That means somewhere in the memory, computer memory, we allocate some space for a new person object, right? It's of type person. And let's say for each person we have an attribute called name. In this case, it's going to be Alan. Okay, and this is just somewhere in the memory, and you can see every place in the memory can be referred to by some address. Okay, that's more about hardware details. You don't have to know too much. But basically, conceptually, you're trying to say P over here. It is not going to store the entire object directly. Okay, it's not. Instead, it is going to say it's going to store the address of this object. So that's why it's pointing to the object there. Okay. So now the question is, when I say p.getName, what can go wrong? Okay? Sometimes you might say p is assigned to null. If I say p is assigned to null, what does that mean? That means p is not going to point to anywhere at the moment. It's simply just point to nowhere, just nowhere. Okay? So now in that case, if immediately following this line, if you say p.getName, what's going to happen? So that means you're trying to call the getName method on a memory location that is stored in P. But there is no such memory location. Now it's a special word in Java to tell you there's nowhere that's in the memory that's being stored. Okay, in this case, you will get a null pointer exception. Okay, now it comes to the question. How can we protect this? Okay, using short circuit very quickly. Okay, I'll give you two versions. Again, let's make a multiple choice, shall we? So P equals now. We'll say GN, get name, okay? Number 2. Or not equal to, okay, I like this example here. P not equal to null, or P dot get name. Think it for a minute. I got 4 versions for you. You can see that 1 and 2 is equals, right? But we are using different operators over here, right? For 3 and 4, I use not equal to, and over here I use different logical operator. Okay, think very carefully. I think this can summarize very well what a short circuit is, again, so I can move on to the next topic. My question is, which ones can crash at runtime? If you think they're all correct, just say they're all correct. You think they're all wrong, tell me they're all wrong. Or it can be somewhere in between. Okay, think about it for a minute. I think this is rather important. I can leave some silence here. Think about it, okay? Of course, I'll give you answer and explain, but I'll rather you think about it a little bit. Okay, 30 seconds, and then I will see if anyone wants to speak out. Okay. Okay, anyone? Should I point to someone? Since we got a small class today, should I point to someone? How about you first? Start with you. Okay, let's go over one by one. Number 1, do you think number 1 is okay or not? You don't think that's okay? I agree with you, but can you give me one example where it can crash at the runtime? If P is null, let's see what's going to happen. Okay, for number 1, let's try to get some idea from number 1. For number 1 over here, okay, let's say if it happens that P is null, let's say null is equal to null, true. If we already got conjunction, the left-hand side being true, should we bother for the right-hand side? Actually, we should, right? Remember the table over here. If the conjunction is actually, sorry, that's disjunction. If it is true, let's say the left-hand side, if it is true, but depends on what the right-hand side is. If the right-hand side happens to be true, of course, overall it will be true. If the right-hand side is actually false, then it can still be false. So that means we don't know yet what the overall result is, right? So that means over here, if it is true, that means we should still evaluate the right-hand side. Okay? What's going to happen when we evaluate the right-hand side? Well, since you can, let's see if you can understand the logic over here. Over here, you can only get to the right-hand side at the runtime if the left-hand side is true. If the left-hand side is true, that means P is null. And you are calling basically null dot some method. So null pointer exception, logically speaking. So this is logically very evil, right? Guys, get the idea? Okay, good. So now, since I talk about number 1, so you can see that number 3, so this is not good, okay? Number 3 should be the fix, right? Because what does that mean? Let's try to understand this from a different angle, logically. If I can get to this right-hand side, that means the left-hand side must be true for conjunction, right? If the left-hand side is true, that means guarantee the context object is not null. So I can guarantee the cost on some object that's not known. So that's okay. Okay, now, what's left will be 2 and 4. Okay, one of them is right, the other one is wrong. Well, you know, since I said number 3 is actually right, so shouldn't number 4 just be right? Should it? Should it? No? Yes, 2 and 4. Which one should be right? Which one should be wrong? 4 is wrong? 4 is right? Okay. If you... Aha. Okay, good. Okay, now help me a little bit. If you claim that, if I understand you correctly, you say number 4 is wrong, right? Okay, how is that wrong? Give me one example. I'll use a different, yeah, I'll just follow what you're going to say. Try. Okay, give me one, how about this? Give me one example value for P you would like to try. P is null. Okay, let me do that first. If you say P is null, okay, and then we're going to evaluate this left-hand side here, what we're going to get? Yeah, null is not equal to null. It's not equal to itself, so that should be false. And now, if for disjunction, the left-hand side is false, should we bother? We should go to the right-hand side, right? Because if the right-hand side happens to be true, overall it will be true. If the left-hand side is false, overall it will be false. So it really depends. Good, okay, good. Okay, so that's false. So that means we should go ahead and write it, go ahead, and then now we get false. Oh, sorry, we'll get null. So now that get name will just crash, right? Null pointer exception. On the other hand, this is okay. Overall, only these two are fine, but I should know why. I might give you something similar in the exam. Okay, hopefully that's fair. Okay. But guys, I think it's not really about the exam. I think you can try, you might know many students from engineering section, right? Maybe ask them if they know what this is. Show them how proud you are, right? To know about short circuit. I can tell you that even for CS graduates, they might have forgotten about what short circuit is, okay? Okay, any question about short circuit? Yes, go ahead. For 2, yes.
Null equals null.
Yeah.
Or null.
Oh, okay, good question. Okay, so since like you're still a little bit confused with short circuit, let's try, okay?
I understand that it's an or.
Yeah.
One or the other, right? Because it's true before it, so it crash the program.
You wouldn't crash because...
Yeah, I understand one, short circuit.
Yeah.
But suppose you switch the order anyway.
Good question. So the question was, for number 2, okay, for number 2, let me just highlight it in different color, and then let's try. Do I have any pink, maybe? Okay, let's talk about number 2 over here. Now, let me create a slightly different version as you suggested. So now let's say P dot get name, or P is null. Okay, now, at the runtime, you're always going to evaluate from left to right. That's always the case. It doesn't change the principle, right? So now if you have P being null, that means you're going to crash right away. You don't even get a chance to check it. That's why the order does matter. It does, right? Okay, so there's a null pointer exception. Okay. Okay, one more remark for you. What's the difference between short circuit and logical operator like conjunction disjunction? Order of evaluation. That's really the difference, okay? So the order of evaluation does matter when you talk about execution. Okay, guys, any more questions before I move on? Okay? I think I kind of go beyond what the question was, but I think, okay, the original question was, how do we understand this example over here? Okay, let's see very quickly, since they refer to this specific number of slides. Let's only look at line number 10. Okay, line number 10. You can see that this is a very good program for protecting this expression over here. You can see that over here, NS is an array over here of index I. So remember, David, you said before, if I is the index over here, that's the value we want to guard against, right? So that's why we say I less than 0 or I larger than or equal to NS the length, right? That's the thing we're guarding. Okay, so that's okay. The indexing.
Something else, I think you said?
Say that again?
You said there's like two things. One, you want to regard an array and
Array and also method call.
method call.
Also maybe division. You want to make sure there's no division by 0. Yeah,
Okay.
yeah, that's the typical cases. For short circuit, you want to guard for array indexing, so you don't have array index, sorry, let me say it again. Short circuit, what's the application? Yes? Short circuit. Typical application would be, you want to apply that to division and also array indexing. Also, you want to method call. Okay, let me just summarize very quickly. You might want to say x not equal to 0 and y divided by x larger than 2. That's one example here. Or you can say I greater than or equal to 0 and I less than a dot length and ai larger than 2, for example. Right? And also here you can say P is not equal to null and P dot get name, maybe something like that. Okay? So these are the typical examples. Okay? Yeah, these are very important details for you to remember because this applies not just to Java. If you program in any C-like language, like a C#, for example, they also got things like this. Okay? Or maybe even Python, I guess. Okay, let's now move on to the next one. Okay, short circuit logic is covered. Okay, something to do with, okay, slide 59, classes and object. Let me see. Can you explain after the bullet point, assuming that? Well, let's see. Let's go to the classes and objects. Okay, where did I say assuming that? Oh, I see over here. So this one over here, let's see. Okay, so this one here, this slide here, I talk about how you can use a dot notation. Okay, let me just write something on the pad. I'll show you just in a moment. Okay. Okay, can you just read through the definition for the class person there? I'm just reproducing it on my iPad. I'll switch my iPad very quickly in a moment. And I tell you what, this is kind of related to your lab number 4, where you have, let's say, point collector, right? For the point collector, you got point number 1, point number 2, right? Similar. It's just for a person, you got only one single spouse. Okay, name, and then person over here, and then spouse. Okay, over here. Okay, so let's say, you know what, this is very interesting. Let me just try to see this. Let me just copy one expression down. Okay, good. Okay, let's try to play with this example. I like this, actually. Okay, now let's try this. Let's try one example here. Let's say, let me use green here. Person, Jin, is new. Let's assume that we got a constructor for initializing the name. I'll just say Jim over here. Okay, for that, after this line, what's going to happen? After this line, in the memory, we're going to have an object over here of type person. And it's really important for you to draw diagram like this. It's not just important for 1022, but for 2030, there will be more complicated programs you would like to trace using this kind of a mental model. Okay, but I'll revisit how you can draw the diagrams when we get to 2030. Okay, over here, how many attributes do we have? We got name, we got spouse, right? So let's draw that. So we have name and we have spouse. Okay, over here, let's assume that the constructor is going to initialize the name into Jim. And it makes sense to say by default, every person is single to begin with, right? So that means the spouse over here, so there are two ways you can draw this. Either you can say by default, first of all, you can see that this is a reference type. Meaning that if you don't give an explicit value to initialize, it will just be null to begin with, right? So let's say initially simply just null. That's one way you can put it, or you can simply draw an arrow over here and just say point to nowhere, either way, okay? Depending on which one you prefer. I personally prefer pointing to nowhere, okay? So now, let's try this. Given that, so this is, let me just say over here, okay, number one, okay? After number one, if we try Jim the spouse dot spouse dot name. You can say, when I say this, it's like a system of print out, right? As I print out this expression here. What's going to happen here? Jim dot spouse dot name. What's going to happen here? Is it going to print out Jim? Is it going to print out Mary? Is it going to print out, I don't know, whoever it is? Or yes. Null pointer exception. Good. But let's see why. Okay, this is how I would process this line over here. Whenever you got dot notation in object-oriented programming language, read from right to left. Okay, you hear me right. Right to left. Okay? This is how I would read it. Read in this direction here. Okay? So now, the first dot is over here, so that means this is the attributes we would like to get. The rest of the expression on the left-hand side, to the left of the dot, what's this? This is the context object for name. The easiest case, of course, was something like this. When you say p.getName, over here you can see the right-hand side, the rightmost thing is getName. So that's the method you're trying to call. So the rest of on the left is actually the context object, in this case just p. But in this case, it's more complicated. Jim.spouse.spouse. So Jim.spouse.spouse refers to an object for which you want to call the name. Okay? So now, let's work out over here. Jim.spouse.spouse. Okay, basically just this part here, all right? Jim.spouse.spouse. If we try to print out Jim.spouse.spouse, what will we get? What should we get? Should we get any objects, or should we get null pointer exception again? Null pointer exception? Okay, let's try. I will analyze to you why. Okay, it's really important to understand this. Okay, over here you can see that. Let's try to do the same analysis again. Spouse over here, read from right to left, that's the dot, and this is the context object for the spouse. Okay? Now, question for you. What's this context object over here? Jim.spouse. Well, Jim.spouse over here at the moment is simply just null, isn't it? So that means you're trying to call spouse on something that's null. So it's going to be null pointer exception, right? That's why. Okay? So it's going to be null pointer exception. Okay, guys got it? Okay. Okay, let's try one more example over here. Okay, let me do another one here. So that's number one. I'll try to separate. Okay. Yes. Yes. It can still be. Yes, that's exactly. Yeah, I'm gonna illustrate that. Yes, good. Very good question. Okay, good. You know what? Let me, I just realized, let me just change the previous one. Let me change that a little bit. Okay, I'll put just over here. Let's say the constructor for the person class does not take any arguments. is simply leave the name also to be null to begin with, let's say. So what we could have done for the previous example was, we can say after that, we can say Jim dot set name to be Jim. Okay, just that's the only change I would like to make, but everything else stay the same. Okay, everything else the same. Okay, now, given this, let me just try to go for version number 2. Okay, let's see this. Is this readable? Good. Okay, let's try this. Let's say person over here, Jim. Okay, that's also, okay, don't get confused. That'll be better. Okay, person Jim is new person. That means by default it's going to be null for the name, but we're going to say set the name. Dot set name to be Jim. Okay, it's the same as before. But now this is what I would like to do. I would say create another person object over here, person, and then or say Mary. New person. Okay? And then let's marry them together. How do we do that? I'm just going to show you in the tester code, but you have to know how to define the method. You can see that from the slides. Okay? So what I would say is I'm going to say Jim dot spouse. At the moment it is null, right? It's going to be assigned to whatever Mary is. Okay, just that. Okay? Let's try to draw the diagram and see how this is going to look like. Okay, so now so this is 1. Okay, and let me just do 2 over here. Okay, 2 over here. Okay, so that means initially we have Jim still. It's going to point to a person objects, and we have name, we have spouse, and then it's going to be Jim. And then it's going to be just null to begin with, right? Up to now. And then how do we create a person called Mary? So I can do Mary is pointing to a new object over here of type person. And then we have name, we have spouse. Okay, you can see that there is no set name for Mary, not just yet, it's intentional. Okay? And then the name is not there, and the spouse is also pointing to nowhere. Okay? So now what I would like to do is like this. Let me just add one more line. And also Mary dot spouse is assigned to Jim. Like that. Okay? If I do that as well, let's try to work out how these two lines are going to work at the runtime. Okay, let's see this. Okay, these two. Okay, what about the first one? When I say Jim, the spouse is assigned to Mary, right? That means whatever address that is stored in Mary, store that in Jim, the spouse. All right. Okay, let's try that. So that means Jim, the spouse, is over here. It's now going to point to wherever Mary is pointing to. Okay. Similarly, the next line over here, Mary the spouse is assigned to Jim. So that means Mary the spouse, which is currently pointing to now, not here anymore, is going to point to Jim. So they're pointing to each other as spouse. Okay. So now, let's see how things are going to work out. If I try the following expression again, if I say Jim the spouse dot spouse, are we going to get any null pointer exception? Yes or no? Okay, I heard some no. Okay, so now let me show you once more. So there are 2 ways for you to read this expression here. Okay, there are 2 ways. What I said before was right to left. If you want to do it from right to left, you want to know this is the attribute I would like to get access to. But for it to work without any null pointer exception, the context object over here must not be null. right, etc. Okay? You can also read it from left to right. How do you do from left to right? You might find it left to right easier, depends. Okay, let's do from left to right. Let me just do this first. Let's say start with Jim. Jim is over here, right? When you say Jim, every dot corresponds to like an arrow. Okay? Jim dot spouse. Jim dot spouse. That brings you to this Mary object, right? Because it will bring you to over here, the spouse. And then when you say dot spouse again, where should we go? You will go back to Jim, right? Because Jim dot spouse and then dot spouse will bring you back to Jim. Guys, does that make sense? Okay. Should I just do one? I think one of the, do me a favor, if you, I'll just illustrate once more. The diagram is a little bit messy. Okay, I'll do it once more. But for the complete story about dot notation, for your tutorial for lab number 5, there is one part where I talk about aliasing and dot notation, where I talk about this more systematically, to refer to that, okay, the tutorial video. Okay, let me do it again. If Jin is pointing to an object over here, and Mary is pointing to a person object over here, okay, we got name and spouse. Over here, we got name and spouse. Okay, the setup we had before, let's say this is Jim. Okay, the name of Mary has not been set up yet, not yet. Okay, so just now to begin with. Okay, and then we say that, let me just use green. Jim the spouse is set to Mary, and Mary the spouse is set to Jim. Okay, that's the setup we have. Let's analyze again the expression over here. When we have Jim dot spouse dot spouse. Okay? So let's try to see this. Let's start with Jim. Where's Jim? Jim is here. Okay, and then we have dot. Go to the corresponding object there. And then when you say spouse over here, that means go to that particular attribute over here, spouse. Okay, and then you will say dot again. And then, so that means follow the arrow over here, you go to the object for Mary, right? And then, right, so far so good? Okay, and then you would say dot spouse. And where's that spouse over here? The spouse is simply over here, right? So that's, so what's that contain? The spouse over here. So the spouse over here is the address of Jim person object. Okay, that's what it is. Okay? Okay, so far so good. And now, if I ask you to say one more, Jim dot spouse dot name. What is that going to be? Jim, right? Because from before, we know that up to now, it's referring to this particular attribute over here, which stores the address of this object over here. So if you say dot again, it's going to follow this link again. We will go back to that particular Jim objects. And then you say dot name. Okay, maybe I use different color here. And then you say name over here. Where's the name? Over here, which is Jim. Okay? Questions? Yes. Yeah, it will go back there. Yes, it will. Yes, yes. So, okay, let's see the difference between, yeah. So now, let me just go a little bit further with this. 1 and 2. So both 1 and 2, you don't have any null pointer exception, you don't. Okay? But they mean different things. When you say gym.spouse.spouse, right? Okay, let me just see, let me just make some. Okay, gym.spouse will give you this object here, and then .spouse will trace you back to gym object, right? So that means this guy over here is referring to a person object. Just a person objects. However, if you try to go a little bit further, you say that given this person objects, I want to get its name. Okay, so that means you want to say not only that I want to get this object here, but give me specifically this attribute called name. That's why you get gym. Okay, it's different. Okay, something for you to think about for this example here. Gym.spouse. Spouse. Okay. You know, how about this? What's that? Well, hopefully, now you can just go through a diagram, right? From left to right. What would this be? Okay, think conceptually. Jim.spouse is Mary. Mary.spouse is Jim. Jim.spouse is back to Mary. Mary.name? No. Okay. Make sense? Okay. You will definitely get something like this on Sunday. So please, make sure you understand. The reason that this is important is, I tell you why this is so important. Because in object-oriented programming, you have something so-called reference type. And the majority of the types you have to deal with in your projects later, you know, either in the curriculum or later in the industry, they will be reference type. And if you got reference type, you always deal with addresses. So that's why you have to be very clear about how your program should behave. You can see that it makes a huge difference. If I simply say gym.spouse versus gym.spouse, right? It makes a huge difference. But you should know what the difference is and see which one to take, right? So it's really important, okay? Any questions before I move on? Yes. Ah, very good. Context object. You know what? Let me just do one more thing for you guys, okay? Context object is really important. When I say, let's start with something very simple. Gym.spouse, okay? The dot is over here. This is the context objects. So this is the attributes, right? Simple case. Let's make it a little bit more complicated. Gym.spouse.name. Like that. Okay? If you want to figure out who the context object is, you should really read from right to left. So the dot is over here, right? So that means for this guy here, this is the attributes. And this whole thing over here, gym.spouse, which is Mary, right? That's the context object. But you can see the context object does not have to be like a simple case like this. It could be, but it doesn't have to be. It can be as complicated as you like. Okay? Let's see another example here. If I have gym.spouse.name. Okay, now let's try to analyze a little bit more here. Again, you can see that over here, okay, there's a dot on the rightmost side. So this is the attributes, and this guy over here is the context objects. The context object itself also has a context object, right? Why? If you look at the pink one over here, okay, this itself also has context object and attributes in this context. So let me use a pink here. So this is, so let me just, again, you can identify the dot is over here, right? And then for that one there, spouse over here is the attributes we are dealing with for this particular context object, right? And this guy here is the context object of the context object. Okay? To make your life even harder, what about this guy, context object here? Can we further divide that? We could, for sure. This guy here is the attributes, and this guy here, back to the base case, is the context object. So the context object, which one are you talking about, depends on the context, right? I know it sounds a little bit funny, but that's the way it works. So my point is, you should really know about this kind of subtlety here. You might be able to do well on the exam on Sunday, I really hope, without knowing this precisely, but you definitely want to know that eventually, right? It will take some reiteration over and over. Okay, guys, any questions? Are we okay? Yeah, we still got about half an hour. Let's see. Okay, loops. Can you explain the error? Let's see what the error is. The loops slide 72. Oh, okay. Infinite loop. Let's see what it is. Okay, let's look at the fragment at the top. Okay, I don't really have animation here, but can we focus on this part here? Okay, just this part. Okay. Okay. So now let me just try to. Okay, can you stare at that point, line number 1, 2, 3, 4, 5, 6 over there? Okay, I'm gonna reproduce that on the iPad, and then we can discuss it very quickly. Okay. Stay there for about a minute. User wants to continue. Okay, and then answer dot equals. Okay, and then while user want to continue is actually true. Okay, and then line number 5, we basically try to update the answer. Is equal to, is assigned to next line. Okay, good enough. Okay, don't worry about the fix just yet. Okay, like that. So now, let's just try to run it conceptually. Imagine that this is the console, okay? So now it's going to read some initial output from the user. Let's say if I say Y at the console, I type as a keyboard, right? And then I type Y there. So now the continue is going to be assigned to whether or not the Y over here, you can see I read in Y, right? Y dot equals Y would be true, agree? So that means I will get true to begin with. While true, that means I should go into the body of the loop, right? And now I'm going to read in again from the user, if the user wants to continue or not. Let's say I do not want to continue anymore. So what should I do? I will type in no. But is it going to help? Because if you try to read in no here, that means the next line is going to take n, no. And answer is also going to be updated to n. However, the continue itself, the answer itself does not control whether you're going to go into the loop or not. So what's really controlling? The truth of continue. So that means continue will always remain true in this case. It's never updated, right? That's why it's an infinite loop. So how do we fix it? Well, yes, go ahead. Yeah, you should really take, you should really somehow reflect how the answer look like into the truthfulness of continue, right? Exactly, okay? You want to suggest what we should do? Go ahead. You want to suggest? Yeah. Yeah. Basically, you can say continue is assigned to answer dot equals y. That'll be the fix, right? Because that means when you enter no, so that means no over here equals y will be false. So that means it's going to assign this to false, and y of false will be exit. Okay? So that's what the slice is about. Okay? Okay, good. Sorted. Any question about this example here? Should I stay longer or? Okay, good. All right, let's go on to the next. Okay, I think up to, oh, this one's new. Can you explain how static? Okay, good. I think that'll be slight. You know what? I want to leave this as the last part. I do want to go over this. Yes. Okay, 77 to 84. I do want to go over that. One moment. Okay, null pointer exception, array index out of bound exception. I think we have gone through them already. Let me just recap. What's null pointer exception over here? Okay, null pointer exception is when the context objects is null. Okay? So whenever you want to say, for example, p.q.r.s.m, right? If somehow, for example, to say, if p.q.r.s is actually referring to null, so that means you cannot call m on the null objects in general. So that'll be null pointer exception. That's just a conceptually. Okay, another one, what's array index out of bound exception? So what is that? It's easy. Whenever you get array indexing over here, the simplest case would just be I. Okay? If I is either too small, negative, or I is too large, larger than or equal to a.length, right? And you will get array index out of bound exception. Okay? So these are the two common exceptions you will get. Okay, good. So that one is sorted as well. Somebody's typing. Wow, that's okay. Will Android specific things be covered? Spinners? Yeah, no. The answer is no. Okay. Yeah, you can stop writing here. Yeah, I was just gonna intervene. Okay, this one done. How can I just answer to this? No. The most thing I would like you to take out from this course is not Android Studio or developing app. I want you to pick up the knowledge from Java. I think that's what really matters. Yeah. Okay. Why are some of the questions on the example exams question the exact the same with different answers? Okay. You know what? This is a very interesting point. Maybe I kind of see what this guy is trying to say. Okay, let me just go back to the sample exam. Let me just give you one illustration that can also help for Sunday. Let me just go here, example exam. Okay. Let me just try to see over here. Let me see if this will be a good one. I think this could be a good one. Okay, is it still readable? Okay, so you can see that, okay, this is question 3 over here, and this is question 4. Do they look the same? You need to have very sharp eyes for Sunday's exam. Do they look the same? Well, to some extent. Line number 1, same. Line number 2, same. Line number 3, also the same. Line number 4, no, right? You can see line number 4, what's the difference here? Persons.length minus 1. So they are different. So here's a point I would like to make. Since we are dealing with programming, sometimes even just 1 character or 2 character difference can make a huge difference. Okay? So you will see lots of examples like this on Sunday. Of course, there's no way for you to prepare for now because I cannot tell you what the questions are. But you want to be very, very careful when you see the questions on Sunday, because maybe I will give you maybe different versions of the same program, but different versions, in which case you have to judge one version by one version. Okay? Okay. But I do want to ask the people who are here, do you have any question about the example exam? Any question you would like me to go over? Yeah, which one? Number 6, absolutely. Okay. Okay, just want to say, whoever asked this question over here, why are some of the questions on this are exactly the same? No, they are different. That's why they got different answers. That's my question. Okay, so now number 6. Okay, let's try to do them together. Oops. Yes, okay, number 6. Okay, let's try them out together. Okay, sorry, I don't have animation here, but let's do line by line. Huh? 7? Oh, you meant 7. Okay, I see. Sure. Okay, let's try. So what we gotta do, you will definitely get a question like this for the Sunday. The best way to solve this kind of a question is draw diagram. Don't try to calculate in your mind, because you'll be stressed out on Sunday. So you better not rely on your mind calculation. Draw diagram, that's my advice. Okay, let's try. Let's go line by line. Line number 1, when we say, let me make it a little bit bigger for you. Okay, that's good. Okay, line number 1. You know what? It's even better to have you concentrate to say that. Line number 1. Person P1, new person Hyun. How do we do that? Okay, I would suggest the following. For those of you who want to try, get a piece of paper right away. And what I'm going to do is I'll let you draw on your side. I'll draw on iPad and compare the answer. How about that? Okay, you really want to practice this. You don't want to practice this in the exam. Right? Okay, for line number 1, how should the diagram look like? I'm going to draw on the iPad now, and then you can draw on your paper, and I'm going to reveal the iPad in just a moment. Okay, so let's give you maybe 30 more seconds, 30 seconds more, and then we'll do it. You can, let's assume we got only one attribute called name in the person class. Let's assume, okay? Okay, first one should be rather easy, right? Okay, line number 1 should give you a diagram like this. Agree? Okay? I hope you can at least draw this, I hope. Good. Line number 2. Similar, right? Okay. Let's draw line number 2 as well. You can see that we're basically creating 2 different instances of the same class. The only difference is one person has name Hyun, the other one has name Ji-yoon, right? That's how it should look like, right? P1 and P2, okay? And then line number 3. So now, what are we trying to do here? Okay, let me just, this one I'll help you a little bit over here. Person array, persons. Okay, array initializer. So we simply put P1 here and P2 here. Okay, P1 and P2, right? Okay. So now, if you try to recall from the previous lecture, this one here is equivalent to the following 3 lines. Conceptually, you're trying to create a persons array of size 2. And then index 0 is going to copy the address for P1. Index number 1 is going to copy the address for P2, right? Something like this. is equivalent to the following. It's like you say persons, new person, size 2. The reason that it is 2 is because you got 1 and 2, okay? And then you're going to say persons at index 0 is going to be assigned to P1, and also persons at index 1 is going to be P2. Okay, so what's so good? What it is equivalent to. So now, how should we draw the diagram, right? So now when you say, let's do this. When you say persons over here, it's pointing to an array of size 2. Okay, that's index 0, that's index 1. And we say that over here, index 0 is going to copy the address for what P1 is storing, right? What does that mean? That means it's going to point to wherever P1 is pointing to. Okay, you know what? Let me be consistent with the color. I better use blue here. Okay, and then this line over here, person 1, persons at index 1 would be P2. Okay, let's try to use green here. So that means persons at index 1 is going to point to wherever P2 is pointing to. Okay, that's what that line would do. Questions about this? Good. Okay, so now after that, this is interesting. When we say P1 is assigned to P2, we are changing whatever that is stored for P1. But what do we change that into? We change to whatever P2's value is. Okay? So P2 stores some address for some person objects. We're going to copy the address there into P1. Okay, let's see that. So P1 is assigned to P2. P1 is assigned to P2. So now, am I trying to do the following to say P2 is going to point to wherever P1 is pointing to? I hope you wouldn't say yes, right? It's no. That's not the way to go. The opposite. Okay? That means change P1 rather than pointing to this, is going to point to wherever P2 is pointing to. So the direction is really important. If you got this step wrong, the answer will just be wrong. Okay? After that, persons 0 is assigned to P2. Okay? Now, can you change your diagram accordingly? And let's see if your answer will match mine. So persons at position 0 is assigned to P2. Okay? Let's see what we should do. So persons 0 is referring to this particular slot, right? So now rather than pointing to there, it's going to point to P2. Okay? That's it. Now, let's see what the next line is. System out of print line, person 0 is equal to P1. Okay, I'll just copy that. So now is that true or false? Okay, let's try. So persons 0 over here, so persons 0 is referring to this particular object over here, right? On the other hand, what about P1? P1 is referring to this object over here, so they are referring to the same object. So it's true. Okay, it's aliasing. So true. Oops. Okay? Yeah, you kind of do the same logic, the same reasoning, the same process for all the other questions. Okay, guys, any other things on the exam? I mean the example exam, before I move on. We okay? How long is the exam? You mean when will be the deferral exam? No, that's not defer exam, that's a remediation exam. If you already apply for deferred standing means you cannot attend the remediation exam on Sunday. But if you can attend, just attend. Then you don't have to go for the deferred one. You cannot go to. Okay, let's talk about offline. I don't think that's the interest of everybody. Okay. Okay, let's see what else. Yes, which one? 8, sure. Okay, let's look at number 8. Number 8 is, okay, over here, right? Okay, now, let's treat it as a fresh problem, okay? So now, guys, do me a favor. Can we try everything up to here? Only up to here. Draw diagram. Okay, I'm going to draw as well. Okay, are we done? Just for up to line 3. Okay? So it should look like something like this. Right? P1, P2, and index 0, index 1 for persons, right? Okay, let's now have a look at the next line. P1 is assigned to persons 1. P1 is assigned to persons 1. That means P1 is not going to point to here anymore. It's going to point to wherever index 1 of the person array is pointing to, which is here. Right? I could have simplified this diagram a little bit. What about I just say pointing here? That makes sense too, right? Okay, it's pointing to wherever persons 1 is pointing to. Okay, next one. Okay, next line over here, person 0 is assigned to P2. Okay, so now we are changing to say person 0, which is here, is not going to point to here anymore. It's going to point to wherever P2 is pointing to. Here. Okay? That's why it happens. Okay, let's go to the next line. And then P2 does set name, Jihei. Okay, P2 does set name. P2 is over here. Let's see here. P2 is over here. P2 does set name. So rather than being Jiyun, it's going to be Jihei. Okay. And now let's go back there. So now print line P1.name. What's P1.name? Jihei. It's not Jiyun anymore, right? Because it has been set already. Okay. So from the previous one, it's actually P2 dot set name. One thing I want to highlight just in a moment. Okay, I'll show that to you. Okay, that's what we did in the previous line. And now that's why finally, when you say P2 dot, sorry, let me just copy that correctly. It's P1 dot name, okay? Okay, now what I want to highlight is this. You can see that over here, the context object for set name was P2, right? However, when we print out, it's actually P1. P1 and P2. So somehow whatever I do using P2 has affected what P1.name would look like. So that's aliasing. right? Because P1 and P2, they are pointing to the same objects. Okay, let me write it down exactly what I meant. Because P1 and P2 point to the same objects. Therefore, change done via P2 is visible to P1. Okay, that's aliasing. Okay. Any question about this? Okay, the issue about aliasing is very important. Okay. Okay, are we okay for number 8? Okay. Any other thing? We are not done yet, don't worry, yeah. Yes? You know what, let me get a little bit closer. I cannot really hear you well. Yeah, say that again. Yeah.
So say you were to change persons at position 1 to something else, P1 would also.
Oh, good question. Okay, let's do some follow-up. Okay, I see what you mean. The question is, what if at this moment, let's say we reassign persons 1 to something else? Is it going to affect other objects, other variable pointing to the same objects? Let's see. Okay, I'll post the question here. It's a good one. Okay, let me put it here. So now let's say there's a change. Let's say we do, just from this diagram here, if I say persons 1 is reassigned to, let me see. First of all, is this going to change anything here? Let's think about this first, and then I'll tell you what the issue is. Just about this change. When I say persons 1 is assigned to P1, should we change any arrow here? Well, basically, we may have to change the arrow for persons 1, but to where? To wherever P1 is pointing to. But P1 is already pointing to where you are pointing to, so you don't have to change, right? No change in this case. Simply because, now I want you to observe something over here. Up to this point, basically all the variable path you can mention about, they all point to the same object, like over here and also over here. They all point to the same objects. And you might be wondering, what about this object here? It will be garbage collected because no variables are storing its address. Okay? Okay, that's the issue here. Okay? Now, another thing I want you to try. So that's change number 1. Change number 2. Let's say we got one more person. Person P is new person. Let's just say A. Just make it simple. Just A. Okay, so that means we have P is pointing to a person over here, and the name is simply just A. Okay, so now if I say persons 1 is assigned to P, so now what should we change, right? So now we are saying that persons 1, which is over here, should not point to over here anymore. Instead, it is going to point to this object here. Okay, back to your question. When we are changing this arrow over here, should we also change other variables who are also pointing to the same object at the moment? The question, so should we also change P1 to here and change P2 to here? That's your question. No, we shouldn't. I tell you why. It's easy to see why. You can see, I want you to see over here. When we say persons 1 is assigned to P, think more about this. It's more like a variable assignment. When we say X is assigned to 3, so what does that mean? That means we want to change the value for just this particular placeholder for X, right? And change it to 3. And when we say persons 1 is assigned to P, there's only one single placeholder we want to change, which is just this. Okay, so we don't have to change others. Okay. Okay, good. Okay, any more question on the example before I move on? Okay, let's see. So guys, you know what I would suggest? Let me just see very quickly what we have over here. Static and non-static, I will cover that between compile time and runtime. So basically, the best way to illustrate this is, I think I'll continue for some other time, but feel free to leave if you want to, but I'll definitely make the recording available. How about this, to avoid disruption? So I'm going to continue with that with a few more questions, maybe take up to 30 minutes, I wouldn't mind, but if you really have to go, I'll give you 1 minute, and then we can continue. Okay. Nobody? You are not obliged to stay. That's okay. I'm going to make the recording for you anyway. You may have other schedule to catch, so that's fine. Okay. Meanwhile, we can take 1 minute's break. How about that? Not too long, because I'm not going to break the recording. Okay. So just 1 minute, and then we'll continue. There will be a sketch paper for you. You don't have to. Yeah. Okay, resume in 30 seconds, okay? It wouldn't take much longer, maximum another 20 minutes, maximum. Yes. How about, what time is it now?
It's about like 3 o'clock.
3 o'clock?
I'm gonna go grab some food.
Sure.
So.
What about come back to my office around 3:30?
3:30?
Mm-hmm.
Where's your office?
It's 2043 upstairs.
2043.
Upstairs. Yeah, upstairs.
All right.
Okay? Yes.
Because I read book the deferral exam, but if I want to attend the August 26th,
Just attend. That's fine. But once you attend, you cannot do the deferred exam anymore.
so if I choose the August 26th, that's it?
That's it.
Then so the deferral exam I don't need it.
You don't need it.
And one more question, what do you mean for the exam about multiple choice about what?
You will see when you come to Sunday's exam.
So, and you also say the multiple choice if someone do the incorrect.
I said in the beginning, so if you get incorrect answer, you just get 0.
But why can't you just cost this mark?
What do you mean?
If the wrong answer will lose mark.
Yeah, if you choose the wrong answer, you lose mark. That's right.
Yeah.
Yeah.
I know this is an easy question, okay? And this so what you talk about is almost for the preparation for the exam. Preparation.
I don't see what your question is.
I mean today's lecture.
Yeah. That's to answer your questions here.
And also, what do you mean API?
Check the slides. There is API there. All right. All right. Okay.
We have break, but it's 3:06 now.
That's why I say if you want to leave, you can leave. I'll just want to go a little bit longer.
So maybe what? When does it end?
I don't know. That's why I'm just want to keep going a little bit.
Well, I think it's almost time to leave.
You can leave. I'm not asking you to stay. That's fine. All right. Okay, guys, let's continue. Okay. Okay. Very quick response to this question here. So the difference between compile time and runtime. Okay. So compile time and runtime. Basically, if you create a class over here, let's just create a very quick class on Android Studio. Just class A. Okay. Compile time is very easy. Whenever you're trying to develop your code using the editor, let's say integer x is assigned to 3, integer y is assigned to 4. You're just typing, right? You're not trying to see anything from the console just yet, right? That's compile time. Okay? What can be the feature of a compile time? If you're trying to use variables in an inconsistent way, if you say integer, let's say string, let's say s is assigned to, let's say x plus y. This is not considered as type correct, right? That's what will happen in compile time. You want to use the variables in a consistent way. Integer plus integer, numbers plus number. Okay? So this is compile time error. And if there's any compile time error, that means you cannot execute your program. Okay? But now what about runtime? Let's say I get rid of this line that's incorrect, and then I can say system.out.println line. Oh, sorry, I forgot one thing here. Okay, can I just add a main method here? Basically, as you're typing here, that's compile time. As soon as you want to see the effects of your program, that will be runtime. Okay, let me just get these lines over here and put it here. Okay, so now if I want to say system.out.println line, if I say x plus y. Okay, now you can see that. Let me just give you one more example. So far, you can see there's no red underline for your program. So that means your program compiles. So you can try to execute it. So you can say right click on that. And now as soon as you say run, it's a runtime, right? It's going to show you the result in the console. Okay, let's see. Yeah, just wait a bit. System.out.println line, class not found. You know what? There's some little bit issue with my setup here, but if you try that on your Android Studio, you should really see 7, right? 3 plus 4 will be 7. Yeah, I should really fix this before I came to the lecture, but I'll fix it later. Okay. Anyway, my point is compile time is whatever you're typing in the editor. Runtime is when you try to execute a program and want to see the effects at the console. That will be the runtime. Okay. So now the multiplication matrix over here, so that one I refer you to, I hope you know, there is a video there for the solution. Let me show you here. Yeah, there's a challenging exercise on 2-dimensional array and there's a solution to it, right? So I would suggest you go over that. Yeah, that will be a very nice exercise on 2-dimensional array. Okay? The only thing I want to mention very quickly is about the nice thing about this exercise over here is for the background section over here, I'm just giving you purely mathematics about how you can understand how the operations can be completed. However, you want to translate them into Java. Okay, that's the challenging part. How about I just do one very quickly? I'll give you some idea. So the way we do a 2-dimensional matrix is by using a 2-dimensional array. Okay, let's say for example, let's see over here, 2, 3, 4, 5, plus 6, 7, 8, 9. Okay, let's do the simple one. How do you add up two matrices together? Okay. So the way to do that is, think about this is the result matrix you want to have, right? So now in general, so let's say I can see I have a void method here, add. So integer m1, integer m2. Let's just make the assumption that their dimensions are the same. Number of rows are the same, two rows, number of columns are also the same. Okay? So now how can we calculate that? Okay? So now this is how you can think of it. Think about what should be the dimension for the resulting matrix. The resulting matrix should be exactly the same as the inputs. So that means, for example, how can I figure out this particular entry over here? Okay? This is the entry. Let me call this maybe M3. What would be M3 at row number 0 and column number 0? What would that be? Well, that would simply be the corresponding place, right? From M1 and M2, right? So that would be M1, 0, 0, plus M2, 0, 0. Okay, that means 2 plus 6 would be 8. Okay, and 4 plus 8 will be 12. 3 plus 7 will be 10. 5 plus 9 would be 14. Conceptually, it's very easy. But how do you figure this out? I'm going to tell you how you can do addition, and then I'll give you a little bit hints about how you can do multiplication. Okay? Multiplication just add one more complication about nested loop. That's something you can also figure out easily. Okay, so now let's talk about N3 first. In general, I can say integer array matrix N3. So now it will be a new matrix over here. And what should be the dimension? Should be exactly the same as M1 and M2, right? So it doesn't matter I use M1 or M2 here. You can say M1 dot length. Okay, how do I figure out the number of columns? Well, assuming that the matrix is not empty, go to row number 0, right? And see how many columns there are, dot length. Okay, so these are the basics of two-dimensional matrix. I suppose you know about them. Okay, if you don't know, review. Eventually, I would say return M3. Okay? Okay, so what should we do over here? I want you to think more from the output point of view. How can I gradually fill in the contents for M3, row by row, column by column? Okay, how do we write a nested loop, row by row, column by column? I can do something like this. For integer r would be 0, etc. Going through the row. Okay, I will leave that to you. Very easy. And then I can also say for integer column would be 0, and then all the way through. Okay? Nested loop. And now, what really counts down would be this part over here. Given a row, given a column. Okay? So now over here, I can say the matrix 3, row and column. What should that be? Well, if you see from this example here, if that used to be 0, 0, should be the same over here, right? Right? So you should put M1 RC plus M2 RC. And do me a favor, that will be very good for your learning. Convince yourself this fragment of loop here really correspond to the math over here. It's a nice mental exercise. Okay? I'll leave that to you. Okay? Okay, the same for addition. I want to do one more thing for you for multiplication. Multiplication, I know it looks a little bit scary because now each entry over there is a sigma. What's a sigma? Well, sigma is just like a loop, right? In some way, right? Did you want to say something before I? Huh? Yeah, well, it's like a sigma, sigma k is equal to 1 up to y, right? Yeah. I suppose you guys learned about it, right? Somewhere. Okay, but that's okay. Anyway, let me give you some idea about multiplication, and then you can do it. Let's see the example I gave to you. Give me one moment. I may not have it here, but let's see over here. Okay, how about here? Okay, this is M1 and M1 and M2. Okay, just give me 30 seconds. I'm going to put it on the iPad. Okay. M2 Okay, let's have a look at that. Okay. Yep. Okay. Multiplication. Okay, the idea is like this. Again, let's think more from the, there is some constraint about matrix multiplication, okay? The thing is, the number of columns over here must match the number, the number of rows over here for M1 must be matching the number of columns over here. They must match, okay? There's some constraint over here, okay? And you can read through the background information a little bit more. But let me tell you exactly how you can calculate, okay? Conceptually, it's very easy. Again, how do I figure out this guy here, okay? So this guy here, let's say it's M3, and 3, and then I want to say 0 and 0. Okay, what is that? Okay, the way to see that is more visually. So when you say C0 over here, that means go to row 0 of M1. This means go to column 0 of M2. What does that mean? Row 0 here and column here. Okay? And do the cross products. Okay? That means 1 multiplied by 5 plus 2 multiplied by 7. And you get 19. So that's how this 19 is figured out. Okay, how about let you try. How do I figure this out? M3, 1, 1. What does that mean? That means I should go to row number 1, column number 1, and do the cross products, right? So that means 3 multiplied by 6 plus 4 multiplied by 8. 50, I think, right? That's kind of the idea. So now you want to figure out a way to go row by row and column by column of M3, and then to figure out exactly how to fill in each entry over here. And to figure out each entry here, go to the corresponding row in M1, go to the corresponding column in M2, and do a loop to do the cross products. Okay? Think about this more. It's a worth doing challenging exercise, and you can see the solution in the video. Okay? Do have a look. It's going to be beneficial. Okay. Let me see what's else. Okay. Is there any exercise we should look at while the example test and tutorial videos if you still have time? The slides. Let me say one thing. You should definitely emphasize the study for the loops and classes and objects. Right? So these are the two you want to focus on. Okay. I want to just say one more thing about, so there might be some other question I cannot really cover, okay? But I want to just say one more thing about the static, okay? Before I let you go. Let me just go to the slide I want to look at. Okay, now let's have a look at this one here, okay? Now let's look at 4.1. When you study for the number of points, number of members, number of accounts, what we say is like an NOP, right, in your tutorials exercise. Now, the only difference is I make it static. Okay? So now how is that going to change things? Okay? That's something I want you to look at. Okay? So now, first of all, what's the difference between static versus non-static? Okay? Let's see that. So now let's have a very simple example here. Class A, integer I, static integer j. Okay, like that. And then I will simply say A over here, just empty constructor, like that. Okay, that's it. Oops. Okay. Let's now see how we can, so no, I want a square. Good. So now how can we see that? Okay. Now let's try this. A1 is new. A, like that. Okay. And then we'll say A2 is new A, like that. Okay, one thing to note, you can see this variable here is non-static because there's no static keyword before that. On the other hand, J is static, right? Static versus non-static. So what's going to be the difference? The difference is for non-static, every object has its local copy. Okay? For the static, all the objects share the same global copy. Okay? But now, how is this going to work? Let's use some very simple illustration. Okay? So now let's try this. If I say A1 dot I is assigned to 3. Okay? And now I want to print line. A1 dot I, print line. A2 dot I. What's going to be the result? Any idea? What's going to be result for 1 and what's going to be result for 2? For 1? 3, right? What about for 2? A2 dot I. 0. So it seems like A2 dot I is not affected by the fact that we assign A1 dot I to 3, right? Yes, questions? Yes, so if you talk more about the access to static variables, you can refer to the last lecture back in I think March. That one I talk more details. But here I'll just briefly summarize. But yes, you can. Yes. You know what? I'll briefly talk about here in just a moment. Okay? So now how do we understand this? So A1 is pointing to some object of type A, and then the I over here is initially 0, and then A2 is over here A, initially 0, right? And over here, when I say A1 dot I is assigned to 3, that means only change this local copy here to be 3. So that's why A2 dot I is still 0. Okay, that's one thing to note. Okay, local copy, non-static. Now, what about, let me just do another one here. Let's say 3 here. Oh, let's now do A1 dot J is assigned to 4. So now back to your question there. There are two ways for you to refer, there are two different ways for you to refer to a static variable. Either you can use the instance name, like A1 or A2, and the static variable name. That's one way to do it. But Android Studio might give you a warning, not error, just a warning. You could have done the following way. You can simply say A dot J, the class name. So this means J does not just belong to a particular instance. It belongs to the whole class. That might be a little bit more meaningful. Okay? So now, so you can either say capital A dot J, or you can say A1 dot J, either way. But now if I say A1 dot J is assigned to 4, now what if I say print line A1 dot J print line A2.j. What would that be? In this case, they will both be 4 because it's shared. The way to draw this would be something like this. You can just put aside a box for all the static variable, like a global counters, a record, and then put a class name over here. And then J is not being pointed to by any objects, right? It's shared. And J here, when you say A1.j is assigned to 4, just put 4 here, right? It's not being shared by both A1 and A2, right? Just 4. So that is why if you refer back to our very last lecture back in maybe March the 5th, no, not March, back in April, end of April. So I think in that last lecture, I talked about static versus non-static. I would suggest you refer to that for the more systematic introduction. So here I'm just showing you something very quick. Okay. So now, one thing I would like you to check by yourself, because I don't have much time left, but I do encourage you to think about how this is going to work. So in the tutorial and your lab, we usually just put integer number of accounts, for example, right? But now I put a static into it. So what does that mean? So now I'm just going to verbally tell you what the issue is. I want you to verify that by yourself. I do want you to try. If I just illustrate to you, you might just forget, okay? Also, we don't have much time. What's the issue over here, okay? Guys, let me just make sure you can understand what the code should do. Could you please just read over these lines from here up to here? Read it through very quickly. So when I talk about issue, it will make sense to you, okay? Shouldn't be too strange to you. That should be very familiar. That you just did in lab test 3. Everything should be familiar except that it's static rather than non-static, right? Okay, so now I'm going to go through the code just verbally, and you can re-listen to the recording later. Okay, now let's say we got Bill and Steve. Okay, we got 2 clients over here, Bill and Steve. And then we have 2 accounts, ACC1, ACC2, right? So now think about this. Because we declare the clients over here, each client should have, okay, I got option for you. Does each client have their own copy of the number of accounts counter? That's option number 1. Option number 2, do all the client objects share the same number of accounts counter? Option 1 or 2? Share, right? Because that's static. That's really crucial. That's the difference here. That's deliberate. That's why it's a common error. Okay, understanding this, let's try this. Initially, number of accounts should be 0, right? Now, let me ask you this. When I say bill.add account, it's going to add to position 0, right? At the same time, for Bill, it's going to say number of accounts plus plus, which will go from 0 to 1. But is that change from 0 to 1 also visible to Steve? It is, because this is a global counter. So that means when you try to say Steve.add account, the number of accounts counter does not start with 0 anymore. It's starting with 1. So that means when you go to the Steve's clients array, index 0 stores nothing. It will store in 1 directly. Okay, that's the issue. Okay, it might make sense to you, but you better try. Okay, that's my last word for you over here. Okay, any more questions? Yes. I would say as you only have to know to the extent that I show in the example. Yeah. So the question is, how much should you know about array list or hash table in the API? My answer is just study the example I gave to you. Make sure you can play with around similar example, then you'll be fine. Okay. Has any more questions for me?
Can you just repeat the answer again for the accounts, the add account?
Okay, again, okay, let me just highlight once more, okay? So when you rewatch the recording, you will know. Over here, the number of accounts counter is static. That means Bill and Steve, they share the same counter. It's not local to them anymore. So that means when you say bill.add account, it's going to correctly store at position 0. However, when Bill increments the counter from 0 to 1, that counter there is also visible to Steve. So that means when Steve.add account happened, it's going to store into index 1 rather than 0 to begin with. That's the issue. Okay, guys, that's pretty much it. But do you have any question for me before I stop the recording and let you go? Any questions? How many questions? Well, I don't want to say the exact number, but close to 50. 50. Guys, I tell you what you should do. Sleep well for Saturday. If I may suggest what you should do for maybe today can relax a little bit, since I know 2.5 half-hour lecture is very dragging to you, for your attention. This is what you should do. Maybe you start your study again tomorrow. Go over the slides for loops and classes and objects, every slide carefully. Okay? That'll be it. Okay? Just go over that. And on Saturday, maybe you can just see what issues you might have, and maybe try to, if you really want to post some foreign question, I'll try to answer if I can manage some time. But I would say I can tell you really want to focus on classes and objects. Static versus non-static. You can refer to the last lecture I gave back in end of April. And also for the loops, focus more on the nested loop. And do the challenging problem for two-dimensional array. That will also help. Okay, anything else? But if you ask me if the exam will be hard, I can tell you that it's hard. But everything that's on the exam, I can definitely trace it back to somewhere on the slides. So that means I'm asking you to definitely go over the slides. Okay? Sorry, say it again? I will only test the very important ones. For example, what's aliasing? Right? Yeah, only the important one. The definitions are not the focus for the exam. The exam will be more about reading code. Okay? Okay, study this also for your 2030. Okay, you will find that you have much easier time if you study very hard for this exam and understand as much as you can. And when 2 weeks from now, when you go to 2030, you will find in the beginning 1 or 2 weeks, if you are in my session, you will find quite a bit of reiteration. Okay, if you are in my session, yes, yes. Are you gonna write any code on the exam? On the paper? You might have to write some code, yes. Yes, get prepared for that, but not much. A little bit, yes. Format will be the same, yes. Yeah, I try to make the format the same, and also the level of difficulty the same, so it wouldn't be unfair. Yeah. The same format, yeah. Not the same question, the same format. Yeah. Well, similar. Would be similar. Okay, anything else, guys? Anything else? Are we good? Oh, yeah, sure. Yeah, the challenging exercise for two-dimensional array. So if you go to the course website there, okay, you will see that the second last lecture, here, the lecture about two-dimensional array, you will see challenging exercises and also solution. The solution was recorded a while back, so you may have to raise the volume for your speaker a little bit. Yeah, I didn't have this kind of equipment at that time, so. Yeah. Okay, guys, any question you will ask me about? Okay, good luck. I'll see you on Sunday, and hopefully I will see you again in 2030, okay? Thank you.